Welcome back to G Fun Facts Online, the podcast where we dive deep into the coolest science and tech breakthroughs. Today, we're plunging into a world of invisible forces and underwater wizardry. Ever thought about moving things underwater without even touching them? Sounds like something out of a sci-fi movie, right? Well, hold on to your headphones, because science is making it a reality. For years, controlling objects underwater without direct contact has been a slippery challenge. Imagine trying to assemble something delicate on the seabed or guide a sensitive sensor through murky waters. It's tough. Traditional methods often involve clunky robotic arms or are limited to tiny particles. But what if I told you we could now command objects underwater using just sound? And not just any sound, but sound sculpted by incredible new materials called acoustic metamaterials. These aren't your everyday materials. They're engineered with super tiny, intricate structures, smaller than the wavelength of sound itself, that give them almost magical abilities to control sound waves. So how does this underwater magic work? One of the biggest game changers is that these acoustic metamaterials can remotely manipulate surprisingly large objects in water. Previously, acoustic manipulation was pretty much stuck with tiny things, like objects smaller than the sound wave trying to move them. But metamaterials flip the script. By coating an object with a specially designed metamaterial layer, scientists can precisely control how sound waves bounce off it. This creates specific forces that can push, pull, and even rotate objects. Think of it like having invisible hands made of sound. And get this, a really cool innovation was unveiled in May 2025. Researchers developed a metamaterial with a unique sawtooth pattern surface. Picture tiny, sharp teeth on the material. When sound waves from different directions hit these teeth, they reflect in such a way that they can exert different forces on the object. This allows for incredibly precise pushing and rotation. They've successfully demonstrated this with all sorts of materials like wood, wax, and plastic foam, both floating on the surface and completely submerged. For those submerged items, they've even achieved full three-dimensional manipulation. That's like having an underwater drone that moves things with sound alone. Now, you might be wondering, how do they even make these complex materials? Well, that's another area where we've seen huge progress. There's a new technique using a metal resin composite and something called soft lithography. This allows them to create features on the metamaterial at a sub-millimeter scale, that's super tiny, and achieve a high acoustic impedance contrast with water. This contrast is crucial for them to work effectively underwater. The best part? This method is low cost, relatively easy to use, and overcomes hurdles that made it difficult to create these materials before. But wait, there's more. Scientists aren't just stopping at moving one object one way. They're exploring clever methods, like surface pattern superimposition and frequency multiplexing. Fancy terms, I know, but basically, it means they can embed different manipulation instructions within a single metamaterial patch. This could lead to much more complex operations. Imagine controlling multiple objects at once, guiding them along specific paths, or even performing non-invasive maneuvers without disturbing the surrounding environment. The potential here is mind-blowing. Think about underwater applications. This could revolutionize how underwater robots operate, making them more versatile and delicate. It could help with transporting and assembling structures on the seabed, or even improve underwater sensing and communication systems. No more bulky grippers needed. And it doesn't stop at the ocean floor. The principles of using sound to manipulate things in liquid are hugely relevant to the biomedical field. Our bodies are mostly water, right? So these acoustic metamaterials could one day be used for remote surgery without large incisions, for precisely targeted drug delivery right to where it's needed, or even for levitating and moving things inside the body. Imagine that, tiny sound-powered machines working inside you, guided from the outside. Of course, this field is moving fast. Researchers are constantly working to develop smaller, more flexible metamaterial patches. The goal is to make them even more adaptable for all sorts of situations, from intricate tasks in underwater robotics to incredibly delicate medical procedures. We're really at the dawn of a new era of contactless control. So the next time you hear a sound, remember it's not just for listening. With acoustic metamaterials, sound is becoming a powerful, invisible tool, promising to transform how we interact with the world, especially in those hidden aquatic environments, both engineered and biological. What an amazing world we live in! That's all for this episode of G Fun Facts Online. Join us next time as we uncover more fascinating facts from the cutting edge. Until then, keep exploring.